Okay, so this was already rationalized. Anytime you have one that's rationalized, what you want to do is you want to go back to the unrationalized version. So to undo this rationalization, what would it have been? Negative 2 over root 3. So now we have secant of theta is equal to negative over root 3. And now we have to remember that secant, I lost my C, secant is the reciprocal of which one? Cosine. So instead of x over r, it's going to be r over x. So now we're going to set up our quadrants, and we know all students take calculus. So we know secant and cosine are the same. They're the same signs. So because the secant is negative, that means we're going where cosine is negative. Well, if cosine is positive in quadrant 1 and quadrant 4, that means it's negative in quadrant 2 and quadrant 3. So we have to create these two triangles, one in quadrant 2, one in quadrant 3. So let's go to quadrant 2 first. And here's theta. We know I'm going to assign, because the hypotenuse is always positive, so I'm going to assign that negative to the denominator. So we know x is negative root 3, and we know r is 2. So it looks like I have a root 3, a 1 root 3, and a 2. Isn't that x root 3 and a 2x? So what kind of triangle is this? This is a 30, 60, 90. What does theta have to be? Well, if it's 30, I heard somebody say 30. Across from the 30 would be x, and then across from the 60 would be x root 3. Does that make sense? It does. So now, if our x root 3 is 1 root 3, that means our x is 1. Okay, so we have to find this angle. So if this is 30 degrees, what does this whole angle have to be? 150. So we have theta is equal to 150, or if I make that 30-degree angle over here, this is 180, right? So this is 180 plus 30, which is going to be 210. Who wants to do more of these problems? I'm going to put just a couple more problems up. If you guys get them right, then I'll stop. If you don't get them right, then I will put more.
Because they're both negative, whatever the angle is, so you have to do another triangle and you should just like create a shortcut.
Okay, you guys try this one. So I'll give you 2. Oh, wait. Not this one. I didn't show you that yet. Are we ready? Who has an answer for me? Should be 2 answers. Perry? No? Leah?
210 and 300.
I got 210. What was the other one?
330.
330.
I didn't even take notes on it.
Who needs to see me do it?
How'd you get 330?
How'd we get 330?
Just do it in the one.
1 is not enough.
The one. Like I got it in the quadrant, whatever. T.
So you got it in quadrant.
3.
So you want me to set it up in quadrant 3 to show you?
No,
Oh, you.
Quadrant 4.
Okay, we could do it the one in quadrant 4. So you used quadrant 3 and you learned that it was 30 degrees. Is that what you did? Okay, once you learn it's 30 degrees and you know which quadrants you're going to, so we're in quadrant 4, that means this has to be 30 degrees. So this is 360 minus that 30 degrees.
I can't add it to.
No, you never want to, oh, sorry. There is an interval, so you need to be between 0 and 360. Always. So you're not going above 360 ever.
Wait, but why do you subtract 30? Like, why don't you just add 2
Why don't we just add what?
Never mind.
Are you sure?
Yeah.
You got it? I don't know what you're asking, but you're okay?
Yeah.
Okay. Do you guys want another one? How many people got that correct?
Like basically.
All right, we want one more? Let's do the cosine of a half. Oh, sorry, cosine theta equals a half, not cosine of a half, sorry. Cosine theta equals a half. And again, we're between 0 and 360.
Is 210 not an answer for?
210 is not an answer. How would you get to, oh, no. For E? Yeah, no, it was 2 answers. It was 210 and 330, but Kate only wanted me to do the 330 one.
How do you get 210?
How did we get the 210? So, did you know you're in quadrant 2 and quadrant 3?
Yeah.
Okay, so quadrant 3, quadrant 4. You knew what I meant. All right, did you know it was 30 degrees?
Yeah.
Okay, so once you know, that's the hardest part. Once you know what the reference angle is, this is 180, and then we're increasing 30 degrees to that. So it's 180 plus 30, which is 210. All right, so you all are trying cosine theta equals a half, and we're on the interval from 0 to 360. Okay, so what should you have done? We know that cosine is positive, and where is cosine positive? It's positive in quadrant 1 and in quadrant 4. So we know this is adjacent and hypotenuse. So adjacent to theta is 1, the hypotenuse is 2. Do we recognize this as a 30, 60, 90? Which means this must be root 3. So what angle does this have to be? 60, because across from the 60 is the root 3. So now we're doing everything in reference to that 60-degree angle. In quadrant 1, your angle is your angle. So this is 60 degrees. Our theta is equal to 60 degrees. But now we could also recreate this in quadrant 4. So now when I do 60 degrees in quadrant 4, isn't this 360, but now minus 60, which brings us to what? 300. How many people got that? Much better. Good. Okay, so now we're going to move on to the special cases. Okay, so remember, the sine of theta is y over r. And so for y over r to equal 0, what has to be 0? Y. Can r be any number as long as it's not 0? Yeah, it can't be 0, but it could be any other number and it will still yield a 0. So we know y is equal to 0. So we're thinking, okay, well, in our unit circle, we have 0, 360, 90, 180, no parentheses here, sorry, and 270. So here we're 1, 0, here we're 0, 1, here we're negative 1, 0, and here we are 0, negative 1. I want y to be 0. Where is y 0? It's 0 at 0 and it's 0 at 180. So theta is equal to, or the sine of theta is 0 at 0 degrees and 180 degrees. We don't use the 360 because once you go that 360 degrees, what are you back at? 0. Okay, let's say I say cosine of theta is equal to negative 1. Well, we know cosine is x over r, and r is always what? Positive, right? Yeah, on the unit circle it's always 1, but isn't it also always positive? So what does this tell us? This tells us x has to equal negative 1. So we're going to look, we're 0, 360, 90, 180, 270, 1, 0, 0, 1, negative 1, 0, and 0, negative 1. So where is x negative 1? Only at 180. So theta can only be 180. So now let's say okay, let's put some things together. Say I want you to find the cosine of 60 plus 2 sine squared of 30. So remember, when you have that sine squared, this is the same as saying 2 times the quantity of sine of 30 squared. So you first find the sine of 30, then you square it, then you multiply the 2. And here is cosine of 60. So I want you guys right now to find the cosine of 60 and find this whole thing. So you evaluate cosine 60 and 2 times the sine of 30 quantities, 30 squared. So you're just making your special triangles in your quadrants, right? These are both special triangle angles, 60 and 30.
Are we keeping, like, for these types of triangles, would be like x, x, or are we keeping the x?
Well, the x's should cancel. Like if you want to do it based on the unit circle, you can. It's the same idea. Do you see what I mean when I say the x's cancel or no? Okay, so when you do the cosine of 60, actually, guys, I'm just going to go over this. So all students take calculus. When we're 60 degrees, we're in quadrant 1. And in quadrant 1, is cosine positive or negative? Positive. Aren't all of the trig functions positive? So I know whatever I get for this is going to be positive. So here is my 60 degrees, which means this is a 30 degrees. So opposite 30 is x, opposite 60 is x root 3, opposite 90 is 2x. If you do not want to use the x's and just think of it on the unit circle, so it would be 1 root 3, 2, that's perfectly fine because the x's are going to cancel. So here, when we want cosine, we want adjacent to 60, which is x, over the hypotenuse, which is 2x. This is what I mean when I say the x's cancel. They will always cancel the x's. So you don't have to put them in if you don't want to. You could sort of set it up on the unit circle. So this is 1/2. And now we want to find the sine of 30. So again, all students take calculus. 30 degrees is in quadrant 1. Opposite the 30 is x, opposite the 60 is x root 3, opposite the 90 is 2x. But this time when we're saying we want the sine of 30, we want opposite, which is x, over the hypotenuse, which is 2x. And once again, the x's cancel. So now I have 2 times 1/2 squared. We square the half, so now we have 2 times 1/4. So 2 goes into 4 twice, so now I have 1/2 plus 1/2, which gives us 1 whole, is our answer. Okay, last problem we're doing. Say I want cotangent squared of 300 plus cosine squared of 120 minus 3 sine squared of 240. I need to make these into special triangles. So I need to make the reference angle either 30, 60, or what was the last one? 45. So we need to make the reference angles either 30, 60, or 45. Are we ready to see, or are you guys trying this on your own? Are you trying it on your own? Okay, good. Try it on your own and then we'll go over it.
How do you
What's up, Kate?
how do you turn them into different,
So,
like, whatever 300 into? Well, I could
So
put
you're gonna go-
300.
yep. So you're gonna go. This is 360, right?
Mhm.
So if you're 300, you can do
Oh,
60.
oh, I
You
see.
see that?
Yeah.
And then that's the 300.
Okay.
So you're trying to get to the closest part. Okay. Who has an answer? One person? Who needs more time? One person? Who has given up? Guys, who's not playing? Got an answer? David, what'd you get?
No, I put cotangent for 30 instead of 300, so.
Oh. Morgan, what'd you get?
1/3. I know what it is. Gosh, I don't know.
Okay, let's do it. So we have to find each reference angle. So I'm going one at a time, right here. So we still need the all students take calculus. So if we're at 300, this is 0, 360, 90, 180, 270. So if we're at 300, we're right in this quadrant. Do we agree? But now remember I said we need to make a special right triangle. So how do I get to 300? By subtracting the 60 here, or making that 60 degree. But now we also want to remember that tangent in quadrant 4 is negative. So no matter what I get here, that cotangent is going to be negative. So if this is 60, we have x root 3 over here, we have x over here, and we have 2x. So we know cotangent is going to be x over y. So that's going to be x over x root 3. The x's cancel. So now I have negative 1 over root 3 squared. Does everybody see how I got from here to here? Did I lose anybody? Because that was a big step. Okay, now let's go on to the next one. So now we have cosine of 120. Remember, this is 0, 360. This is 90. This is 180. This is 270. So 120, once again, all students take calculus. 120 degrees is in quadrant 2. I'm going to drop and make a right triangle out of it. So this, once again, is 60. So this was 60 for us. This is another 60 for us. But in quadrant 2, is cosine positive or negative? Cosine? Not positive. Cosine is negative in quadrant 2. So I know whatever I get, it's going to be negative. So now we have x root 3, 2x, and x. So we want for cosine adjacent, which is x, over the hypotenuse, which is 2x. What do we end up getting here? Negative a half. Right, and the last one. We have the sine of 240. So once again, we are all students take calculus. Now, if I am 240, this is 0, 360, 90, 180, 270. Do we agree we're in this quadrant 3? Now, what do I do to get from 80 to 270, or 240, I mean? I have to add 60. So once again, it's 60 degrees as a reference angle. So now we're 30, 60, 90. Opposite the 30 is x. Opposite the 60 is x root 3. Opposite the 90 is 2x. In quadrant 3, is sine positive or negative? Negative. So I know whatever it is going to be negative. So we are opposite, which is root 3 over the hypotenuse, which is 2. Now I'm going to take all of these values and sub them in and simplify. So we're negative 1 over root 3 quantity squared plus negative a half plus negative root 3 over 2 quantity squared, but then we're still timesing or multiplying that by 3. Leah?
Wait, so are we supposed to square root? Like not square root, like...
Oh, I forgot to square this one. Sorry, this one was squared also. Is that why your hand was up, David?
Couldn't you, like, the way I did it for, like, the third one, the sine 240,
Mm-hmm.
was, like, I went all the way around and I did a little 30 triangle, so that, like, where the 60 is, like, right next to it, I drew a 30 there, so that you would
So,
stop at 240, I guess, like, a little bit before 270. But then we would get, like, different triangles.
ooh, you can't. Okay, so you made like a triangle like this.
Yeah. And then, like, a little 30 up at the top.
Yeah, I did 32.
I'm not sure why that's, like, wrong, per se.
So you did 270.
Like, I started at 0, and then I went all the way around it.
So
30 degrees.
So then you went from 0 to 90 to 180, and then, but you didn't go to 240. Because if you went from 240, from 80 to 240, that would have been here. Do you see what I'm saying?
Oh, okay. I get it.
So by you doing 30, you're doing a negative 30 because you're subtracting the 270. You're subtracting from 270. You're going now clockwise, not counterclockwise. So you always want to keep your reference angle positive. Okay, let's keep going here. So now when we square this, we're going to get 1 over 3. When we square this, we get 1 over 4. When we square this, we get 3 over 2. So now we are 1/3 plus 1/4, oops, sorry, not 3 over 2, 3 over 4. And then 9 over 4. I'm going to subtract these two first since they're common denominators. So now I'm 1/3 plus negative 8 over 4. Well, what's negative 8 divided by 4? Negative 2. So now 1/3 minus 6 over 3, I just made a common denominator, we end up getting negative 5 over 3. Okay, so that's the end of this.